Hey everyone, this is Algebra 2. It's extra practice for differences of squares and cubes. So our objective is going to be simplifying polynomial expressions using polynomial identities. And then here's the standard that we've been focusing on. This is the same standard we've been working on throughout all of Algebra 2 so far this year. First we're going to take some notes on the front side of this page. There are three identities that we're responsible for. We need to know right there, those three. We're going to walk through these four examples to practice. And then at the end, we're going to go and you're going to work on these 6 examples and check your answers with your intervention teacher. All right, so let's dive right in on the front. These are the identities that you discovered in your Algebra 2 class. So you should have found these together as a class. They may be in a slightly different form, but here they are. So if we have a squared minus b squared, that's called the difference of squares. Difference of squares. And it's the same as, we should have found this in your Algebra 2 class, that it's the same as a minus b times a plus b. So that's our first identity. We'll see how we can use it later on. The second identity is a minus b times a squared plus ab plus b squared. And then the third one, that one's called the difference of cubes. It's called the difference because we have subtraction of cubes. And it's cubes because both of the terms are cubed. The last one is called the sum of cubes. And it simplifies to a plus b times a squared minus ab plus b squared. So looking at these, the sum of cubes and the difference of cubes, they're pretty similar. They just have that one minus sign that's different in the first term and in the second term. And then our difference of squares is pretty straightforward. So because we can break these up, so what this is saying is we can take these differences and break them up into smaller parts. And then what we're going to do now is use those to simplify expressions that have division. So we've solved problems like this before. This is a division problem. We could go on and do our tabular division method or long division, but we're going to see a different way to do it today that'll help us do it a little bit faster. So first we want to identify which identity we might want to use. We're trying to use identities to simplify these. If I'm looking at this expression, I look at the top, I see, we have a square here, and 625, is that a perfect square? I could check in a calculator. If I took the square root of 625 in a calculator, it would just give me 25. So sure enough, these are both squares, so we should be able to apply one of our identities, difference of squares. So first we're going to use the difference of squares, diff of squares. And it has a form like this. It's something squared, a squared, minus b squared. So now that I matched up which identity we want to use, I just need to pick out what my a and my b are. Well, a is, in this case, just x. Because I just matched those up. I'm going to zoom in on this. I matched those up, and a and x are that first term squared. And then to find b, well, I could just make a little equation using these two. I could say b equals, or b squared equals 625, which means b would be equal to, take a square root, 25. So we figured out what identity we want to use. We want to use difference of squares. We picked out what our a and b terms are going to be. So now let's rewrite it so it looks most like a difference of squares. Originally it's going to be x squared minus our b squared, which is 25 squared, all over x minus 25. So now we just made it look exactly like a difference of squares. We rewrote it so it looks just like this thing I'm going to highlight in blue up here, a squared minus b squared. On the bottom, we have x squared minus 25 squared. So that's the same setup. Okay. Now we're going to use the identity. We know it's equal to, I'm going to highlight in orange, a minus b times a plus b. So going down here, it's equal to x minus 25 times x plus 25. And on the bottom, we still have our x minus 25. Now there should be something here, sorry, the 25 is a little sloppy. There should be something here that simplifies. On the top, we're multiplying by, x minus 25. And on the bottom, we're dividing by x minus 25. Well, those are inverse operations. When we have inverse operations, we can cancel one on the top and on the bottom. And then we should just be left with, it's going to be x plus 25. Okay, so overall, we figured out which identity. We picked an identity. We found our A and our B. And then we rewrote it and simplified. That's just one example. Let's try out another one here. This time, now that we have this overall process, we'll be able to walk through it a little bit more quickly. So for example 2, again, the first step I want to do is pick out which identity I think is appropriate. I see that there's a squared here. I look at 49 and I think to myself, 49, is that a perfect square? Yeah, square root of 49 is 7. 7 squared. So I think I want to use difference of squares again here. So difference of squares. And that's going to look like a squared minus b squared. So I just put my term on top. Now we want to match up and pick out what our a and our b are going to be. So if we take our time here, it looks like a squared equals 25x squared, and b squared equals 49. So if I simplify those, I need to take square roots of both. Square root of 25, well, that's just 5. A equals 5, and then square root of x, square root of 25 times square root of x squared. Well, the square root of anything squared is just itself, so it's going to be 5x. And then the square root of 49 is going to give us b equal to 7. So we picked which identity we want to use. We matched up our terms. We figured out what our a and b are. Now we just have to plug it into our, rewrite it. So I'm going to write out, again, our identity, a squared minus b squared equals a minus b times a plus b all over, nope, that's it. So for us now, 25x squared minus 49 is going to be equal to, a is 5x minus b is 7 over or times 5x plus 7. Let me zoom in on that. So we rewrote the top of our expression using this identity. Now the bottom of our expression, I'm going to highlight in blue and add it down here. It's 5x plus 7, 5x plus 7. And again, we see this same term, this blue term, this 5x plus 7, is showing up on the top and on the bottom. When we have something multiplied and something divided, we can cancel them out, cancel, and we get 5x minus 7 left over. So let's look what we've done here. In these first two examples, we identified our identity, we rewrote it and simplified, and we got the quotient, we got the result of dividing these two without having to do our reverse tabular method, which remember is a lot of steps. So take a second now, pause this video, and in the next video we'll wrap up on these last two examples. But for right now, take a couple seconds, see if you can apply this process to 3 and 4, and then when you want to check yourself or when you're stuck, tune back in and we will finish those up. Let me